All right, so we have here another topic under uh, electrochemistry. We have here spontaneity of redox reaction. So before I continue, may I know what is the meaning of spontaneous? Okay, so basically spontaneous in Tagalog we called it kusang loob. Right? I hope nagets na natin. So for us to be able to uh, deeply understand the topic. Okay. So we have observed that voltaic cells use redox reactions that proceed spontaneously. Any reaction that can occur in a voltaic cell to produce a positive EMF must be spontaneous. Consequently, it is possible to decide whether a redox reaction will be spontaneous by using half cell potentials to calculate the EMF associated with it. So in this topic, no, we can predict the reaction if it will occur or not, if it will be spontaneous or not, using the half cell potentials. Okay, let's uh, have an example. Let's try to answer your self assessment or self learning assessment. Okay, we have here. Okay, we have here uh, solid zinc plus 2 iron 3 plus will yield to zinc 2 plus plus 2 iron 2 plus. All right. So from this equation, we could get the half uh, half reaction. Okay. We have here zinc will yield to zinc 2 plus. So for us to balance the charges, we need to add 2 electrons. And based from the table from our previous topic, the standard electrode potentials, standard reduction potentials, no? But this one we observe that this is oxidation reaction, no? So therefore is 0.76 volts. Kapag reduction kasi siya, it will be negative based on the table. But since it is oxidation, therefore it is positive. Okay? So we have another half reaction. 2 iron 3 plus, 2 electrons, 2 iron 2 plus. And we can observe that this one is reduction kasi nga ang electrons ay nasa reactant. So therefore, standard reduction potential, we can check our table. We have 0.77 volts. Okay, so our standard, yeah, our standard electrode potential will be plus oxidation. So 0.77 volts plus 0.76 volts equals 1.53. And we can observe that our standard electrode potential is greater than 0. Therefore, the reaction will occur. So this will, or the reaction will occur at standard conditions. Standard conditions, it means at 25 degrees Celsius and at 1 atmosphere. Okay, so we have here exercise number 2. Okay, copper solid plus 2 hydrogen will yield to copper 2 plus and hydrogen gas. So first is we need to split the reaction into two. Okay, so we have here Cu solid lead to Cu 2 plus how many electrons is needed? So there we need 2 electrons. Okay, so we observe, we notice that the electrons is located on the right side of the equation or in the product side. So basically it's an oxidation reaction. So we have here uh, standard oxidation potential, and based from the table we have negative 0.16 volts. Okay, and the other half equation is 2H plus 2 electrons will yield to H2. Okay, so so since it is oxidation, therefore it is reduction. So the value of our standard reduction potential is 0 based from the table. So there, we can now compute for the standard electrode potential. We have here E cell naught is equal to E red naught plus E ox naught is equal to 0 plus negative 0.16 volts. So therefore, we have here cell potential which is negative 16 volts. And since E cell naught or standard or our cell potential is less than negative 0 point or greater than, okay, so our E cell naught is less than 0. Okay, so we can conclude that the reaction will not occur at standard conditions. So E cell naught is less than 0. Okay, let's try the last example or the last exercise. Okay, so we have here our last example. 2 bromine aqueous plus iodine solid. Okay, plus liquid bromine and aqueous iodine. Okay, so we can now split into two half reactions. So we have I2 plus 2 electrons will yield to I 2I negative. So it is reduction. So standard reduction potential. So we can find the value. We have 0.54 volts. Okay. And the other half reaction we have 2Br negative. We have Br2 plus 2 negative. So we have oxidation reaction. So therefore we have our standard oxidation potential. We have negative 1.09 volts. So we have our cell potential or standard voltage plus E. So we have 0.54 plus negative 1.09. So we have how many? Negative 0.55 volts. And we can conclude that our cell potential is less than 0. So therefore the reaction will not occur at standard conditions.